one, we're going to find the radius of convergence and the interval of convergence for this series. To make this one a little easier, we're going to rewrite this. So for the denominator, so I'm going to let this be my a sub n here. So I'm going to go ahead and keep my n squared x to the power of n. For my denominator, this is really 2 times 1 times 2 times 2 times 2 times 3, and then you're going to have 2 times n. So for this piece, we have 2 to the nth power. And then since we're going 1 times 2 times 3 times all the way up to n, that's like n factorial. Set backwards a little bit. So that's going to be n factorial. So now that I rewrote that, and I'm just doing it so we can use the ratio test, I can also simplify this as n times x to the nth power divided by 2 to the nth. And when I rewrite this, this would be n times n minus 1 factorial. It's going to help later on. So the n's cancel. So now my a sub n is going to be n times x to the power of n divided by 2n to the power n times x minus 1 factorial. Now let's use the ratio test. So we're using the limit as n approaches infinity of a sub n plus 1 divided by a sub n. All right, this is going to give me the limit as n approaches infinity, and we're looking at this piece here. So that's going to be n plus 1 times x. We can go ahead and put just absolute value on the x. That's all we need. So we're going to put n plus 1 divided by 2 to the power of n plus 1 times, it's supposed to be n factorial. Let me change this to n. All right. Now, for the a sub n part, what I'm going to do is just multiply by the reciprocal. Dividing by a sub n is the same as multiplying by the reciprocal. So this is going to be 2 to the power of n times n minus 1 factorial divided by n times absolute value of x to the power of n. Now this gives us the limit as n approaches infinity, and this part right here, let's see, we're going to get n plus 1, and then we're going to have this, if you look at these two pieces, that's just going to be absolute value of x. If you look at these two pieces, that's just going to be 2, but in the denominator. And what's left? Then we're going to have basically in the denominator n squared. All right. Once you have that, we can take the limit, and you can see this is going to equal 0. Since it equals 0, the ratio test, the series converges for all reals. If the series converges for all x, then we have r equals infinity. So your radius of convergence is infinity, and it matches your interval of convergence. So your interval of convergence is going to equal negative infinity to infinity. And that's it. Thank you. Have a nice day. Bye-bye.